Hi, it's time for another math easy solution. Today I'm gonna go over an example on integrals, and in this example I'm gonna look back at that trigonometry integral from my earlier video titled Parametric Calculus Areas Example 2. So check that video out because, well, I'll just jump right into the example. Basically it states, recall from my earlier video titled Calculus with Parametric Curves or Parametric Calculus Areas Example 2, which I went over the cow tied to a silo method, and I'll put the link in the description below. And basically from that video, I saved time by using a calculator to solve the following integral. This one right here, integral of r squared, where this r squared is just a constant, just for reference, and then x sine 2x divided by 2 minus x squared cos squared x dx, and then equals to this, and then it simplifies to this right here. And I just used a calculator, that online one, integral-calculator.com, to solve it and get this, which saved a lot of time. But now let's just solve it manually, just to show you how to go about solving it, and just because it's a pretty interesting example, and it's pretty interesting the way to break this down and try to solve this. So let's go ahead and solve it. First off, what I want to notice is, well, we have this x sine 2x, and then we have a cos squared x there. So recall, with trigonometry we want to remove that squared there. So recall the half angle trig identity from my earlier video, put the link in the description below. Cos squared x, this equals to 1/2 of 1 plus cosine 2x, like that. Yeah, so basically get rid of this squared, and then you just double the size of the angle. So this is the half angle trig identity there. Then if we throw that inside, what we end up getting is, and to save time in writing, I'm going to let this integral equal to I. So then we have I is equal to, and I'll take out this constant r squared. So we have a r squared integral now of x sine 2x over 2. So x sine 2x over 2. Subtract this by, and we factor out that r there. So now we have x squared. So x squared, and then plug this in for the cos squared x right there. So x squared over 2, and then 1 plus cosine 2x, and then this whole thing is a dx over there. And again, so we plug in this, remove this cos squared x with this right there. So now the next thing we could do is, we'll simplify this integral even more by removing this square or this 2 there. So factor that out. So if we factor it out, we get a I equals to r squared over 2, and let's fix this r better. And then integral like this is going to be x sine 2x, and now this one we can multiply the x squared inside. So we have negative x squared minus, now we have x squared cosine 2x, and the whole thing dx, like that. So what I'm going to do is, now we have an integral of 3 different parts. I'm going to break this down into the first one here, the second one here, and the third integral there, and we're going to work with those separately. So for number 1, we have right here integral x sine 2x dx when you multiply that inside. Now to solve this one, because we have a product of 2 different integrals, recall or just notice that the derivative of x is dx, so that simplifies. So that's a clue that if we integrate by parts, we could actually simplify this and solve it. So by parts, integration by parts, what if we recall, when you have something like u dv equals to, well, just uv and then v du. So that's just the typical formula. So you can learn more about by parts in my earlier video in the description below. So now that we have this right here, what we could do is, well, let u equals to x, so that du is just equal to, well, derivative or differential is just dx, like that. And then what we have right here for dv, we could let dv equals to sine 2x dx. Remember the dx there, so that the integral of this will have v is equal to the integral of this That's cosine 2x, but then we need to put a negative and then divide by 2. So that the derivative is going to be, well, yeah, derivative of this one, cosine 2x, is going to be negative, and the negatives cancel, sine 2x, and then by the chain rule of 2, those cancel. So that is the integral like that. So that means, well, we could just throw this inside. So the integral right here of x sine 2x dx equals to u, which is x, and then v is there because we have uv minus v du. So then this is going to be right there, cos 2x over 2, and then we subtract, and the integral now is going to be v, which is negative cosine, so we'll put a positive because two negatives become a positive, cosine 2x over 2, and then the du is just, well, dx, like that. So then that's simplified, and we can actually solve that. So then this equals 2, and this one's going to be negative x cos 2x over 2, like that, and then the integral of cos 2x, that's going to be, well, sine 2x, but then we have to divide by 2, and there's a 2 already, so it'll be 4, like that. So yeah, you could just think of it, the derivative of sine 2x is cosine, add the 2, and then those 2 cancels, the 4 will become a 2. So this is what our function is for this one. Yeah, for the first integral right here. So now let's look at the second one. That's the easy one. So for number 2, we have, yeah, this is integral of negative x squared, or just x squared. Integral of x squared dx, that just equals 2. Well, just add a power, divide by that power. So x to the 3 divided by 3, like that. So there it is. So let's just look at now the third part right here, x squared cos 2x, and again we have this cos 2x, like this x squared, similar to this x. When you take the derivative, this simplifies to, well, x dx, so we can actually use by parts again there, and that's what we should do. So let's go 3, which is the integral of x squared cos 2x dx. So again, we'll use by parts. So by parts, and this time let u equals to x squared, so that du is equal to, well, that's just 2x dx, like that. And then dv equals to cosine 2x dx, so that the derivative, or the integral, is going to be, write this neater, the integral is going to be v equals to, right here, sine 2x over 2, like that. Yeah, so we just do that, divide by 2 by chain rule when you take the derivative. So that's what we have. So then this goes down, and we have x squared cos 2x dx equals to u. Remember the formula, uv minus v du, like that. So in this case we have u is x squared, v is sine 2x over 2, like that. And then now we subtract v, which is sine 2x over 2, and then du, which is 2x over 2x dx, like that. So I'll just move this here. Actually, I'll put this, let's move this around. I'll put this in front first, so 2x, and now we have times it by sine 2x over 2, and put the dx there. So that what we end up having is, well, this cancels like that, and that's x sine 2x dx, which is the same as 1. That's x sine 2x dx, like that. So that means this is the same formula, so we just reuse this and throw that inside. This is just 1. So we could throw that formula inside, so then the second one becomes now x squared sine 2x over 2, like that, minus, now we minus, well, this whole thing. I'm going to put this in front of it. So we have sine 2x over 4 subtracted by x cosine 2x. Just put that in front because it's neater. So now we have, what was that again? X cosine 2x. So x cosine 2x over 2, like that. Now we have a minus there, so what I'm going to do is I'm just going to remove this, put a positive like that. This is x, like that, just to save time. So now that we have that, this is sine 2x. Yeah, everything is pretty unique. So we'll just circle this. There is the answer for the third integral. So thus what we have now, we could just add all of these together. I'll erase this, write this neater. So now what we'll have is the integral is, well, r squared over 2, and then just add those up. Well, 1 minus 2 minus 3, like that. So let's go ahead and do it. So we have I is equal to r squared over 2, and I'll just put this extra line to say this is the same thing as going 1 minus 2 minus 3, etc. So then this equals to r squared over 2, put a giant bracket, and now the first integral, the solution of the first one is over here. So again, that's 1. So this is x, negative x. I'll just do this for the first one. Actually, I'll put the positive side. Sine 2x over 4. So sine 2x over 4 minus x cosine 2x over 2. And just to double check, yeah, that's what it is. So yeah, that's why I used a calculator before, because it's super tedious. And now we subtract this by the second integral. That's just answers x 3 over 3, like that. And then the last part right here is that, and I'll put that actually over here. So subtract it, because we're subtracting the third one. So now we subtract x squared sine 2x over 2, like that, and then that's sine 2x over 4. I forgot to put this bracket around, and then plus cosine or x cosine 2x over 2, like that. Now we have this. And now again, to save time, I'm just going to remove these brackets. That's a negative, this becomes a positive, this becomes a negative when you multiply the negative inside. And this is what we have. Yeah, so then what we have is we can add these ones. These are the exact same. That's sine 2x over 4, sine 2x over 4. So then I'll put this here. I equals 2, r squared over 2. And then this is going to be, well, 2 over 4 sine 2x. And then we have over here, we can add these two actually, and those are both negative, so then those will become negative 2 over 2 cosine, or there's an x first, x cosine 2x, like that. And then we have, I'll write this one first, so negative x squared sine 2x over 2, because there's no one else like that, and then this one right there. So we have negative x3 over 3, like that. And I forgot to add before, and then we also have to add a constant there of integration. I'll just add a plus c, like that, on this. So we have an overall just constant of integration when you take the integral, like that. So that's what we get over there. Yeah, now what I've done is I've just copied and pasted the solution here, just to simplify it in the way that they've done it. So as you can see here, we could cancel this, becomes 1 over 2. This is just 1 over, well, just 1. And then the way it has it is it puts the r squared inside, and then we have, so it puts this one first, the x squared sine 2x, and then puts this in the middle. That's this one here. And then we have this x cosine 2x on the third. Then we have that on the right. And also divides that in. So what I'm going to do is I'm going to put this down here, and let's just start simplifying this. So divide the 2 inside and also move this one in front, so we have a r squared over 2, or actually just an r squared, like that. Yeah, we do that. So then this is going to be, take that 2 inside, this negative x squared sine 2x divided by 2, and then divided by another 2, that's going to be 4. Again, just like this right here. And I'm just going to leave the r squared out because I'd rather not multiply it inside. So that's the same one there, negative x squared sine 2x, so that's correct. And then we have this part, that's going to be plus sine 2x over 2 divided by 2 again, that's going to be 4. Again, same thing here, check. I'll just put a check mark there. And then the last one, we have this cosine. Yeah, this x cosine divided by 2. So we have minus x cosine 2x over 2. And then last part here, negative x cubed over 3 times 2, which is 6. Like that, and then just plus c over there. And yeah, there's the same thing, just remove the r's out. And this is exactly the same thing right here. So check mark over there. And now to simplify further, they've written it in this way. So let's just try to simplify the way they do. They use a common denominator of 12. And then they just put everything in and then factor out the like terms. So let's just do what they do just for fun's sake. Okay, so simplify, just to see how they do it, simplify like that. Now we have I is equal to r squared. We're just going to multiply everything by, we'll get the common denominator. It's going to be 12, because here we have 2, 4, 6. So times 3, times 3, times 3, times 3. This one's going to be times 6, times 6. And this one's going to be times 2, times 2. Like that, so that we have 12 at the bottom. So r squared over 12, let's put it like that. Now what we have is this negative x squared. Yeah, negative x squared sine, well, there's going to be a 3 there. Let's put the 3 in front. Negative 3x squared sine 2x over, yeah, the 12's already taken care of. Let's write this a bit neater. Negative 3x squared sine 2x plus 3 sine 2x, and then we have this part there, negative 6x cosine 2x, and then we have there minus 2x cubed, like that, plus c. Let's see if we got this all correct. Yeah, then there's a negative here. It takes a negative out. I'll do that afterwards. I'm just gonna use the common factor there. Or actually, just take the negative out right now. I'm just going to put the negative there. This is going to be positive. This is going to be negative. This is going to be positive. And this is going to be positive. Like that, just because they take this negative out. Okay, I don't know why they do that. So now we have r negative r squared over 12. And then factor this out. We have, put this bracket like that. 3x squared minus 3, because we have a sine 2x like that. Sine 2x, and then we have a minus 3. Actually, that's already taken care of, like there. Now we have plus 6x cosine 2x plus 2x3 or cubed, and then finally plus c like that. And I'll move this over finally there. And this is the exact same one as this one. So yeah, that's correct. So yeah, now you know why I simplified I just used the online calculator in my last video, otherwise it would have taken forever to solve that other example. Anyway, that's all for today. If you learned from this, pretty tedious but pretty detailed way to break down this really just tedious integral, trigonometric integral, and see how to break it down and follow these steps, etc. Anyway, that's all for today. Thanks for watching. Like always, you can download these exact notes in a link below, as well as you can view these on Steemit, and I'll be uploading those shortly after I upload this video. Anyways, thanks for watching, and stay tuned for another Math Easy Solution.